Alright, highway safety engineers test new road signs, hoping the increased reflectivity will make them more visible. So volunteers drive through a test course with several of the new and old style signs and rate which kind show up best. So is this a one-tail or a two-tail test? Okay. Well, the null hypothesis, okay, would be the proportion of people who can see the old signs equals the proportion of people that can see the new signs. Okay, so the new signs provide the, and I'm going to zoom this out a little bit, the same reflectivity as the old signs. This may not make sense to you right now because we haven't done a two proportion test yet, but the alternative hypothesis is the proportion of the new signs is greater than the proportion of the old signs. So the new signs provide greater reflectivity than the old signs. Okay. So what is that? Is a one or a two-tail test? A one-tail test. We don't care if they provide less reflectivity. We're only testing to see that they provide more reflectivity. Is there evidence that they provide more reflectivity? Okay. So that was question A, so that's one-tailed. Question B, what is type 1 error? Okay, well, type 1 error, what's true? H of O. It's true. So the new signs provide the same reflectivity, but we find that they work better. So they actually don't work better, but we find that they do. Okay. Question C, type 2 error. Okay, H of A is true. What does that mean? It means that the new signs provide greater reflectivity, but we find that they don't. We find that they have the same reflectivity as the old signs. Okay. And then D, what is meant by the power of the test? The power of the test is the probability that we find that the new signs provide greater reflectivity. Okay, so it's the probability that we correctly reject the null and accept the alternative. Okay, and if we accept the alternative, then that means that the new signs actually work better. So that's what power is. Okay. And then question E, if the hypothesis test is tested at the 1% level of significance instead of 5%, how will this affect the power of the test? Okay, well, let's draw that out. So let's say that the old signs, I don't know, 80% of people can see them. But with the new signs, let's say it's actually 90%. Okay, so this is hypothesized. This is the actual. Okay, so here's an alpha level of 0.01. And that's this region right there. Because we would only reject this distribution if it fell in here. Okay? And the probability of it falling in there is actually this right here. But then we change alpha to 0.05. So we now have all this. Okay. So we made the region bigger because we'll reject anything to the right of 0.05. So we actually have a larger region, we have a higher probability of getting a sample in that region. So that test is going to be more powerful. Okay. And then the engineers hope to base their decision on the reaction of 50 drivers, but time and budget constraints may force them to cut back to 20. How would this affect the power of the test? Well, sample size, right? So let's remember the defendant is guilty. So we have a choice of n equals 20 or n equals 50. Well, what is n equals 20 going to do? It's going to reduce our evidence. If it reduces our evidence, then it reduces power. Okay, because we know in this test that we want to reject the null and accept the alternative. Well, if we want to reject the null, we want to find it guilty, the more evidence we have, the better. So we'd rather have a larger sample size. Okay, so that's not deep either, that's F. Okay.